Module 4, Lesson 3, Model Planning. The next step that you usually do, or rather perform, is model planning. And in model planning, this involves understanding your data much better and understanding the relationship between these variable or attributes, so that when you go to the process of model building, you will build a model from a well-formulated data. You don't want to build a model that has many attributes which do not contribute to that model. So in model planning, this is whereby you understand the data very well. You look at the way these attributes are related so that you build an effective model. Here in model planning, it involves things like drawing histograms, drawing distribution graphs, understanding correlations, and so much more, as you're going to see. So the first thing you usually do is to describe your data. Let me just write here, describe data. And this is very simple. The way you describe your data, you just copy this guy right here, world happiness file. Let's just paste him here. Once it's here, you just type dot describe like so, with your rounded bracket like so. And then if you run this code now, there's something very interesting and fancy happens down here. As you can see, there is these attributes here. We have count, mean, this is STD, standard deviation, mean, this is minimum value. It's not the same as this mean. This is the average, this is the minimum value, this is the 25 percentile, this is the 50 percentile, which is the same as median. We have the 75 percentile, interquartile range, that is, and we have the maximum. So this kind of attributes, they tell you something about the data. For example, here we can start that the count for this overall rank is 156. As you can also see, all the count, this is just the number of records in these particular columns. So it tells you that all these columns have 156 records. So this is the same as this is the mean, or rather, let me say the average. Average for overall rank is 78, score is 5.4, GDP per capita is 0.90517, etc. and so. And also, if you note, is that we have also the standard deviation. So the standard deviation, in the simplest way you can be able to understand, think of two values, 2 and 3. So if you want to find the average, you'll take 2 plus 3, that will be equal to 5, divide by 2, that will be equal to 2.5. But now the standard deviation is the square root of the variation from the mean. By this I mean the summation of the variation between the first number and the second number, and then find the square root of this variance. For example, we have these two numbers that I've told you, 2 and 3, and their mean is 2.5. So you'll take 2 minus 2.5, which is the first number, minus the mean. This will be equal to negative 0.5, but still you do not consider the negative, you only take 0.5. So it will be 0.5 plus 3, which is the second number, minus the mean, which is 2.5. This will again be equal to 0.5. So you take 0.5 plus 0.5, this will give you 1, divide by the two numbers, which will be equal to 0.5. So the standard deviation in this case will be the square root of 0.5. So the standard deviation is simply the square root of the variance of these numbers that you have been given as compared to the mean. And the last guy I would like us to consider in this list here is this 50%, or rather is called the 50 percentile. It's the same as the median. The median, if you have a number 1 to 10, you rank them in either descending order or ascending order, and then you pick the middle one, is that number which has been displayed here. You rank the numbers that you have and then you pick the middle one. For now, just leave this 25 percentile and the 75 percentiles because they won't be of that much use. So the next thing that we want to do in model planning is draw histograms for these different attributes in this data. And now, if you consider this data, we are considering to make a model for this score. That is a model that can be used to predict the score for world happiness. And in this case, if you consider this overall rank is just an attribute that was added after the data had been analyzed. If you look up here, so this overall rank does not have an effect on this score of world happiness. Neither does the country or region have an effect on this score of happiness. So the attributes that we are going to consider in this case are these, starting from GDP per capita, social support, healthy life expectancy, freedom to make life choices, generosity, and perception of corruption. These are the attributes that influence the score of world happiness right here. So the way we'll draw histogram, if you can remember, we just copy this guy right here and we paste him here, and we use this guy curly braces, and now we are going to start with the score, histogram for the score. Make sure you put it in quotes like so, and so you just put dot hist and your rounded bracket, and then you run your code. So this is the histogram that appears for the score, and just to make it appear more clear, you just use bins, and let us say we put 20. So as you can remember, bins are these vertical bars, so I'm increasing the number to 20 so that it can be well spread and appear visually well. So this is now, after increasing the bins, this is what happens. So what this tells you is very simple. If you look at this, let us say, for example, this is around 18 countries that have an happiness score of around 4.5. Now, I've included this data here to help you analyze your graph well. For example, now from this graph, we can say we have around 18 countries which have an happiness score of about 4.5. And that 4.5 score here, it corresponds to this relative happy. So you can conclude that from this sample, we have around 18 countries which are relative happy generally. If I come again here, I can say this is around 6.2. So again here I can say we have around 16 countries that are generally happy. Because if you look down here, 1 to 3 represent unhappy, 3 to 5 relative happy, 5 to 7 happy, 7 to 8 happy. So from our sample here, we have very few countries which are very happy. That is, if you look here, the happiness score between 7 and 8, this around, let us say 3 countries that are happy from our data set here. So this is how you can understand if your data is balanced, so that when building the model, you don't build a model that is kind of biased. So the next guy that I'm going to draw here is the GDP per capita histogram. So let us just write down here world underscore happiness file. Let us say GDP per capita, like so. Then this is our guy hist. Then inside here I'll just pass bins and then 20. And so if you run this code, you can see we have the histogram for GDP per capita. But for this one, I will leave it for you to analyze, as we have just done the first one. This will be your homework to do the analyzation before we go to the next part of this code. So I've just included a comment here that will help you analyze this histogram and make some simple deduction from this histogram. So the next guy that I'm going to draw here is the social support histogram. So let me just copy this guy right here and paste him down here, and just change this code inside here and change it to social support, like so. If I run my code, you can actually see here we have the social support histogram, and if you can see here we have 0.0 up to 1.6. so you can divide these into 4 different categories. As such, let me include just a comment here so fast and say 0.0, this is up to 1.4. This will be low social support. Then if you come 1.4 to 1.8, sorry, this should be 0.4, 0.0 to 0.4, and then 0.4 to 0.8. Let us say average social support level. Average social support. And then this 0.8 to 1.2. This should be, let us say, high social support level. And lastly, 1.2 to 1.6, this should be very high social support level. Very high social support level. So I hope you understand what I'm doing here. I've divided these columns, or rather these 0.4 to 1.6, which represent the level of social support, into 4, so that we can define, let us say, for example, from 0.0 to 0.4, we have around, let us say, 2 countries. You can say from our data sample that we have 2 countries which have a very low social support level. As you can see from this data sample, you can say something like we have many countries, which is about 27 countries, that have a high level of social support. So I've just included again this comment to help you analyze and understand your data. This will be your homework, so make sure you go and analyze and understand this histogram before we continue. I hope you have understood the trend. So let me add the other 3 histograms very fast before we see how now to draw distribution graphs. And you don't want to see me typing this thing over and over again. Let me just stop it here, and after I'm finished, I will continue. So now let us continue and pick up from where we left it. I've included the other histograms of this data so that you can be able to analyze at your own time and understand. But now let us jump into distribution graphs. And suppose you might be wondering, what are these distribution graphs? Distribution graph, they are just kind of an histogram, but now they have a distribution curve above them. And you might be wondering, why should we even draw these distribution graphs? It is because, you know, the histogram reveals the information about the data, the sample data that you have, that you are using in this project. But now remember, what you're doing, you want to find an underlying information about the general population. For example, this is just a sample data that we have of 150 records. But now I want to draw from this data, I want to draw conclusion about the world. So histogram just gives you information about your data, but now distribution graphs, which are very, very important, they give you information about the general population. Suppose, for example, you want to get information about your customers. Assuming you are working for a company that wants to get information about their customers. Let us say you have collected a sample data of 1,000 customers. But now you are trying to analyze this information from these 1,000 records and draw conclusion about the general population. For example, let us say from these 1,000 records, you find that most people in these 1,000 records that bought your product are between the age of 25 to 30. Now, using the distribution graphs, you can make a conclusion that larger number of your customers falls between the age of 25 and 30, which means even if you go somewhere else where you have not picked your data, your customers will still fall between this range of 25 to 30. So distribution, they are very, very important because they help you to draw some, I cannot say conclusion, but some very intrinsic and important information about the general population, which can be of very, very much value. Let us say if you're working for a company. And in this case now, we want to draw a general information about the world. For example, you want to realize if in the world the generosity level is high or low. Let us say if the world happiness level is high or low, which are kind of very good information to understand how this data is connected to the overall population. I hope you have understood. So, to draw distribution graphs, the first thing that you need to import is the Seaborn package. And the way we did it, if you can remember, I'll just write import Seaborn as SNS, as simple as that. And now to draw the distribution graph, I'll use this SNS alias dot distplot. This is plot a distribution graph, as so. Then I'll put my bracket as so. And then inside here I'll just pass the data that I need to draw the distribution graph for. In this case, I'll start with the world happiness underscore file, and in this case I'll start with the score to see how happiness score in the world is generally distributed. So if I run my code down here, this is the graph that is drawn. And if you can see, we have a line on top of this histogram. This line on top of this histogram gives us some very, very important information about how the happiness score, or rather let me say the happiness level, is distributed in the world. When you see this line is kind of symmetrical, that is, it is nearly bell-shaped, what it means is that the happiness score in the world is normally distributed. That is, when you consider the happiness level, of course it is not practical that everyone in the world will be happy, because people have different problems. Let us say it ranges from diseases, death, accidents, and why some people have good health, others have bad health. So you won't expect that in the world generally people are happy. So this graph is generally telling us that in the world that is what we are actually expecting. So if you can see this graph, if I can draw a line here in the middle here, it means that this other side of the graph will be nearly equal with this other side of this graph, or let me say will be nearly equal with this other side of this curve, since this curve is kind of symmetrical. So what this means is that starting from this level, which is the level of happiness at this point is very low, but the level of happiness at this point, it is, let us say, average, and the level of happiness of this point is very high. So if you divide this, it means that we have an equal number of people who have a very low level of happiness to an average level of happiness, as compared to those who have average level of happiness to high level of happiness, which means the number of people who are generally very happy and not very happy is nearly equal. That is known as normal distribution. So the next guy that I like us to plot here is the GDP per capita. So what I'm going to do is just copy this guy here. I'm spending time here so that you can be able to understand, and once you have understood this, it can be very, very easy to analyze any kind of information that you have been given. So let me write here GDP per capita. Boom! By the way, GDP per capita, just think of it just like the level of the economy of a particular country. And to be specific here, the level of economy of a particular country measured per person. That is, they calculate the level of economy of a particular country and they divide by the number of the population of that country. For example, let us say they calculate the level of economy for United States of America and they get that it is 5 million. And when they divide by the number of these people, let us say they have around 1 million people. You'll find that 5 million divided by 1 million, you get 5. And again, if you come, let us say, to Germany, let us say the overall GDP, it is 2 million. And if you divide it by, let us say, their number, it is again 2 million. So you'll find that this gives you 2 GDP per capita, but that of United States will be 5 GDP per capita. That is 5 million divided by 1 million. 5 million divided by 1 million. Germany, 2 million divided by 1 million. So in these cases, if you have 5 GDP per capita of United States and 2 GDP per capita, you can say the GDP per capita of United States is higher than the GDP per capita of Germany. What simply this means is that the economy of United States is well advanced as compared to the economy of Germany. I hope you have understood. And so if I run my code down here, let us see this guy. Boom! And there we have this guy. And now, if you can look closely to this guy, we have kind of a bell shape, but now this shape of ours is kind of leaned. This is on your right. That is, according to the way I'm looking at the computer, it is on your right. And so, which means more of this data is shifted on your right side. This is generally known as rightly skewed distribution. And by this, it means that more countries, that is the conclusion that you can make from here. In the world, we have more countries that have generally high GDP per capita. More countries falls on this other side, which means we have many countries that have generally high GDP per capita in the world. The next guy that I'm going to plot here is the distribution graph for perception of corruption. And I'm doing this deliberately so that you can see something here. So let me just paste this guy here. I'm not going to write this code over and over again. And if I run my code now, what you can see right here is that now this graph for perception of corruption is kind of lean towards your left side, which means more of this data is biased on the left side. What it means here is that we have many countries where people have a very low perception of corruption. That is the easiest conclusion you can make from this graph. So I hope you have understood what this distribution graph tell you about the general population. Usually we have three graphs. This is the normal distribution, which is usually kind of bell shape, and then we have this which is rightly skewed. It is leaned towards your right, and then we have this guy left skewed, who is leaned towards your left. So those are the three graphs that you will find them in distribution, and they give you a general information about the general population. So let me just go and plot these other guys down here and add comments, so as you go through them you can be able to understand. And let me pause here so that you cannot see me again typing this over and over, and once I'm finished we can pick it from there. Now the next thing that you do after drawing the histograms and the distribution graph is to find the correlation in the attributes of your data. And now you might be wondering, what is this correlation? Correlation in the simplest language is just the relationship between variables. And here I've drawn two graphs that will help you to understand what correlation is. Now let us say, for example, we have these two variables, eating healthy and being healthy. These two variables are correlated, and in correlation we have either positive correlation and negative correlation. By positive correlation I mean the more you increase one variable, the other variable also increases consequently, which means, for example, here we have eating healthy and being healthy. The more I eat healthy, the more I become healthy. And when this is drawn in a graph, is usually represented by kind of a straight line, like so. The more I eat healthy, the more I become healthy. This is usually represented in a straight line which starts from your left to your right, but in an increasing manner. And so we also have the negative correlation. The negative correlation is where two variables, when you increase one variable, the other one decreases. For example, if I eat healthy, my chances of being sick decreases. And so this can be represented by a graph which starts from the top to the bottom. And if you consider this makes sense. It's nothing harder to understand here, because for example here we have eating healthy is 0 from this data that I have here. Let me just print the data so that you can see what is happening here. So if you look here closely, is that if you can remember, the arrange function create an array from 0 to 10 in this case. And so here we have eating healthy is 0, and being healthy in this case will be 0. Eating healthy when is 1, in this case will be 3, since I'll be multiplying by this 3 here. So it goes like that. When I increase the values of eating health up to 10, also the value of being healthy increases up to 30. And so this value will go like this, 0, 0. If I have 1 here, we'll have 3 here. So it will be top on the first point. So if I have 4 here, here we'll have around 12. So it will be top as compared to the previous points in this graph. So the graph will go like that in a straight increasing manner. And if I consider negative correlation, if I'm eating healthy, this other guy is decreasing. So while I'm increasing, this other guy is decreasing. That's why the graph is going like this, up to down. One more thing to consider with correlation is that this correlation can also be represented in numbers. That is usually a value between 0 to 1. That is positive correlation. And negative correlation, they're usually represented by the value of 0 to negative 1. In this case, if you have a correlation value between two variables ranging from 0.5 to 1, that means these two variables are strongly correlated. And by this we mean, I've also added a comment here to help you understand. By this we mean that if you increase the value of one variable, the other one increases with nearly the same degree as the first one. But if the correlation value in this case is 0 to 0.5, that is, it's less than 0.5, it means these two variables are loosely or poorly correlated. And this means is that if you increase the value of one variable, the other one increases with a very small percentage or no increase at all. Let us take two variables which are strongly correlated. If you speak about eating health and being healthy, those are strongly correlated because when I increase one, the other one increases with nearly the same percentage. But if we talk about reading code and coding skills, if you increase your level of reading code, it does not necessarily improve your skill for coding. Even though you can say it improve a little bit, but they are very loosely correlated. That is, they have a correlation of less than 0.5. So I hope you have understood. Strongly positive correlated, they have a value of 0.5 up to 1. Loosely or poorly positively correlated variables have a value of 0 to 0.5. Let us also consider the negative correlation. In negative correlation, the value ranges from 0 to negative 1. And if you have two variables with a correlation value of 0.5 to negative 1, they are strongly negatively correlated. That means if you increase one variable with a certain percentage, the other variable decreases relatively nearly to the same percentage. For example, love and hatred. If you increase love with a certain percentage, hatred decreases with a certain percentage. They are directly negatively correlated. Or let me say they are strongly negatively correlated. When you increase one, the other one decreases with nearly the same percentage. But we also have loosely negatively correlated values. These are variables which, when you increase one variable with a certain percentage, the other one decreases with a very small percentage or nearly no decrease at all. For example, writing and traveling. Traveling might influence my writing, and hence when I travel, I might not be able to write. But these two variables, they are not correlated in a very specific way, since I might be writing at specific time and I might also be traveling at specific time. And so me continuing traveling won't necessarily affect my writing. So these are negative correlated variables. And I hope you have understood that we have strongly positive correlated variables which range from the value of 0.5 to 1, and loosely positive correlated variables which range from the value of 0 to 0.5. And then we have strongly negative correlated variables which range from negative 0.5 to 1, and then we have loosely negative correlated variables which range from 0 to negative 0.5. If you have understood that, then it will be good for us to continue and see how we can apply in building our model. So you might be wondering, why should you even include, or rather even use, correlation while building our model? The reason is, the first reason is that we want our model to be as accurate and as perfect as possible. And number two, we don't want to include those attributes which are not related to the factor that we are looking for. For example, in our case, we are building a model that will predict the score of happiness in the world. So in this case, we need only to include those attributes which are strongly positively or strongly negatively correlated to the score attribute. And so as we have seen, strongly positively correlated values have a value of 0.5 to 1, and strongly negative correlated value have a value of negative 0.5 to negative 1. And so the way you can print correlation between all the variables in your data is simply like this. You just type the name of your data set, and then you use the function known as score. You just write like this. This will be world underscore happiness underscore file dot core, like so. Let me assign it to a variable known as core, like so. And then let me also add a comment so that you can be able to see it while going through the code. Correlation, and let me just print the correlation down here. So all this should be in brackets there, like so. And here is the correlation after me printing this code. Now the only thing we are looking for here, we want what attributes are correlated to this score value. And you can see here we have the overall rank, which of course it is correlated, but it is not of use here since it was added after we had collected the data, so it does not affect this correlation. But in this case we have score, which correlates to score, and it has a value of 1, so this we do not include since it is the same attribute as score. But if you consider here, we have GDP per capita correlates to score and has a positive correlation value of 0.79. This is kind of very interesting. This means that the GDP per capita is strongly positive correlated to score. Also, if you consider social support, it's also strongly positive correlated. Also, if you consider healthy life expectancy, it's also strongly positive correlated. Also, freedom to make life choices is also strongly positive correlated to score. But if you look at generosity, this is below 0.5, so you leave this one, and also you leave this perception of corruption, which is 0.38. So the one that we'll be using to build our model for predicting the score of world happiness will be GDP per capita, social support, healthy life expectancy, and freedom to make life choices. So you can go even further if you want to see this in graph to make sure that the data that is being displayed here is good, or rather it is in line with what you expect. You just use the SNS alias which we imported earlier, the Seaborn library, and in this case we just say pair plot, like so, and then we'll pass our data here, which is world underscore happiness underscore file, as simple as that. And if I run this code, this should be pair plot, and if I run this code now, and boom, there we have it. These are nearly how many graphs? 1 2 3 4 5 6 7 8, nearly 64 graphs, yeah. And so we are not interested in all these graphs. We are only interested in this line of graphs that affect the score attribute. If you remember, the positive correlation is kind of a straight line. So from this graph you can see we can plot a straight line on this graph, and this is the correlation between score and this second guy. This is GDP per capita, and if we look up here we saw that the relation between GDP per capita and score is 0.7983 and so. And also if we look here, this other guy, we can also draw a straight line here, which means also score is positively correlated to this guy. This is the social support, as we saw up here. So these graphs down here will just help you to confirm the values that you've just gotten up here. Now, if you want to visualize these correlation values in a more beautiful structure, you can use what we call the heat map. And the way you can use the heat map, you use it from the Seaborn library, and this is what you do. You just type sns.heatmap like so. Then inside here you pass two values. We have the correlation value, which we calculated here above, this guy here, this core value. And then next value that we pass here, the next parameter is you just write a note and just set it to true, a Boolean function, and then just run your code. As simple as that. And once you run this code, this is what displays down here. So we have the same kind of structure, but now this looks more clean and more beautiful. We just leave these ones because these ones, like for example, overall rank corresponds to overall rank 1. So you don't pick this guy. But here we're interested with this score guy. And in this case, we do not pick also the overall rank and the score guy. So the guy we are going to pick is the GDP per capita, the social support, the healthy life expectancy, and the freedom to make life choices. So these are the 4 variables, or let me say attributes, that we are going to use to build our model. The next step that we are going now to apply is model building. This is where now we are going to work with these 4 variables in order to build our model.